In this lesson, we're going to start taking a look at algebra, and today we're going to look at algebra expressions. All right, and we've talked about the difference between expressions and equations. Today will be just expressions, no equal signs. And quick reminder on just a couple of definitions. Algebra is the branch of mathematics that involves math expressions with variables. The variable, remember, is whatever can change, the base word vary. And because we don't know what that value is at the moment, we use a letter in its place. So a letter in algebra is called the variable. And as we said, we're going to be looking at algebraic expressions, which have to have some combination of at least one variable, at least one number, and at least one operation. And remember, what we do with expressions is we evaluate. We'll talk about we evaluate expressions and we solve equations. So for today, we're going to evaluate each expression. And to evaluate expression, what we do is we take the rules we're given. Anytime you're given an expression, you will be also given a set of rules to use with it. In this case, here are our rules. We have m is equal to 3, n is equal to 7, and p is equal to 9. So let's look at a few examples of this. The first one we're going to look at is m plus n. And what you need to do to start with is change the values of the variables. All right, so m, we know from our rules, is equal to 3. So in place of the m, I'm going to put a number 3. And n is equal to 7. So in place of the n, I'm going to write a 7. So now my problem becomes, instead of m plus n, it becomes 3 plus 7. And I know that 3 plus 7 equals 10. There I've just evaluated that expression. The next one is 5p. The first thing we have to remember is, what does it mean when you have a number right next to a letter? Remember, a number right next to a letter means multiply. Anytime you see a number right next to a letter, you're going to multiply. So this becomes 5 times whatever p is, and our rules tell us that p equals 9. So this becomes 5 times 9, which I know equals 45. So 5p equals 45. Let's look at my next example, which is 6m squared. Now, one extra new piece here. I'm going to put my 6. I know from the rules that m equals 3. So 6, number right next to a letter, means times. But I also have this exponent 2. So now I'm not only evaluating expressions, but I'm reviewing, going back to my order of operations. If you remember, order of operations tells us that we do all exponents before multiplying. So before I do the 6 times 3, I have to first do the 3 squared. I know that 3 squared means 3 times 3, which is 9. So this becomes 6 times 9. And 6 times 9 is 54. So as we've talked about, what you have to keep in mind and what you have to always remember is that we just keep adding steps. All right, now we're doing evaluating algebra expressions, but we still have to remember and still have to apply the correct order of operations as well. So it just keeps adding one more step. All right. Let's look at our next example. I've got one more row of examples here. We're going to do m squared over p. So I have m squared. If I go back up, m squared, I know m is equal to 3 in my direction, so I have 3 squared, fraction bar, and I know p, going back up, equals 9. So I have 3 squared, fraction bar 9. Now the first thing I'm going to remember is that I do exponents first. So I have 3 squared is the same thing as 3 times 3, and I know 3 times 3 equals 9. I have 9 fraction bar 9. Now, the other piece I have to remember is, what does the fraction bar mean in algebra? Remember, anytime you see a fraction bar in algebra, that is another way of saying divide. So now I have a division problem. I have 9 divided by 9, which equals 1. All right. Next, we're going to add in some decimals. We'll add in some decimals. I have 2 and 5/10. Number right next to a letter means multiply, so times. And if I go back up to my rules again, times m. m is equal to 3. So times 3 plus 2.5. And all of that on top of the number 5. A lot of order of operations things still going on here, even after I'm done with my plugging in the numbers. So now I need to break it into steps. Let's look at just the top part first. Let's look at all of this up top. I have 2.5 times 3. Remember, multiply first. So let's do 2.5 times 3. 5 times 3 is 15. 2 times 3 is 6. Plus the 1 is 7. All right, I have one number after the decimal point in my problem, so I should have one number after the decimal point in my answer. So that part is 7 and 5/10. But I have to add to that, this 2 and 5/10. So I'll take 7 and 5/10 plus 2 and 5/10. Bring down my decimal point. I have a 10 there. And I have 10 here. So everything on the top equals 10. I'm going to just rewrite that here. I'm trying to kind of keep things organized for us here. The top is 10, the bottom is 5. Now, as we remember, fraction bar means divide. So what this really tells us is 10 divided by 5, which equals 2. So after all of my steps, I should end up with an answer of 2 for 2.5 times m plus 2.5 divided by 5. Okay. I'm going to clear things here to get us some space before we take a look at one last example, and that's our n plus 2. All of that squared over 3. And I need to go back up to my rules. N is 7, so I have 7 plus 2 squared divided by 3. Remember, when the exponent is outside the parentheses, that means do everything inside the parentheses first, and then do it to that exponent. So this becomes 7 plus 2, I know is 9. This becomes 9 squared divided by 3. And I know 9 squared means 9 times 9, which is 81. So I have 81 divided by 3. That one's maybe a little bit big to do in my head, so I'm going to actually write that one out here. 81 divided by 3. And 3 goes into my 8 twice. 2 times 3 is 6. 8 minus 6 is 2. Bring down the 1. I get 3 goes into 21 7 times. 7 times 3 is 21. There I have it. All right, so after all of that, my answer should be 27. So the new part with evaluating expressions is plugging in the numbers for the variables. Then use your correct order of operations, one step at a time. Evaluate to get your final answer. Right? That is working with expressions, algebraic expressions, and evaluating.